Imaging in mirrors. A plane mirror is a flat mirror. When you look into a plane mirror, you see a reflected image of yourself. This image appears to be behind the mirror, is the right way up, but is laterally inverted. So letters and words look as though they've been written backwards. So you can use a ray diagram to show how an image in a mirror is formed. The real rays, the ones leaving the object and the mirror, are shown as solid lines. The virtual rays, the ones that appear to come from the image behind the mirror, are shown as dashed lines. However, each incident ray will obey the law of reflection. Colour. White light is a combination of different colours with a different frequency. White light can be divided into a spectrum of these colours using a prism, which is a triangular block of perspex or glass. Light is refracted when it enters the prism, and each colour is refracted a different amount. This means the light leaving the prism is spread into different colours, which is known as dispersion. So there are 7 colours in the spectrum, and you can use the mnemonic Richard of York gave battle in vain to remember the colours. So it goes red, orange, yellow, green, blue, indigo, violet. And there are 3 primary colours of light, which are red, green and blue. And light in these colours can be added together to make the secondary colours magenta, cyan and yellow. And all 3 primary colours add together to make white light. The way coloured light mixes is different to the way paint does. When light hits a surface, some is absorbed and some is reflected. The light that is reflected is the colour of the object. For example, a blue object absorbs all the colours of the spectrum except blue, so therefore it reflects blue light. So if you used different coloured lights and you had different coloured objects, so at the top here is the colour of the object itself, and this is the appearance in different coloured lights. So the colours that the object can reflect, so a white object would reflect all of the colours, a red object would reflect red, and a green object would reflect green. So in white light, a white object would appear white because all the colours are reflected. Red object would appear red because red is reflected. And green object appears green because the green is reflected. In red light, a white object would appear red because there's only red light to reflect. A red object would also appear red, but a green object would appear black because the red light would be absorbed. In green light, a white object would appear green. A red object would appear black because the green light would be absorbed. The green object would appear green. In blue light, a white object would appear blue. A red object would appear black because the blue would be absorbed, and a green object would appear black because the blue light would be absorbed by the green object. And you can then go on to look at filters. So if you had a blue filter and a red object, because blue filter only lets blue light through, the red object would absorb that blue light and therefore it would actually appear black. So objects appear black in white light because they absorbed all the colours and reflect none. Objects also appear black if any single colour of light, if their colour is not the same as the light. As an example, a green object appears black in any other light other than green or white, because there is no green light shining on it to reflect into your eyes. Detecting light. Cameras and our eyes detect light In each case, they have a material that is sensitive to light and a change that happens when this material absorbs light. So the camera. Cameras focus light from an object onto a photosensitive material using a lens. In an old-fashioned camera, the photosensitive material was camera film. When the film absorbed light, a chemical change produced an image in the film, which was called the negative. This was then used to produce a photograph on photosensitive paper. In modern cameras or the cameras in a mobile phone, the photosensitive material produces an electrical impulse, which are then used to produce an image, which can be viewed on screen. The eye. The eye focuses light from an object onto the retina. The retina contains several cells that are sensitive to light. They produce electrical impulses when they absorb light. And these impulses are passed along the optic nerve to the brain to produce an image.